Welcome, I'm Bill Wake. We're here working on a Hangman game written in a programming language 10th that's really kind of like 4th, and it's going to use our interpreter we've written. All right, now I know we left off with something wrong, and I fixed it like 2 seconds after the show, and I meant to write down what it was. I put it in the comment, but probably you may have already gone by then. Let's see. Oh, wait a minute. Hang. The Wrapped, thank you for subscribing again. All right. So I think what it was, I think I had assertions. Maybe we had moved this to the other file, the test file, but really we wanted to write some in this file. But I think that may have been all it was. It was very, very minor, whatever it was. Hopefully it'll pop up if we care. Okay, so I'm just going to pick what we have, run this again. Okay, and so, well, here's test string answer. Boom. Okay, well, didn't fix everything. Oh, another thing I did. Well, okay, we know initialize wasn't working, so that's not maybe surprising. Let me do that again. All right, let's look from our code's perspective. Okay, so we had initialized saving the answer string, and looking at that, I just don't know what we were intending there. It looks like we were trying to make a two-string array, and then we set out to do that. We wrote a couple of tests, but didn't implement anything, and yet it's not clear to me, like, do we really need the string? I guess, do we need the answer as an array? I guess it would be useful, but I'm not sure this did it. Well, answer. Okay, wait a minute. Answer is an array, right? Answer. Okay. Yeah, so we have, in the game, we're going to have the word that they want us to guess is going to be the answer. And the guess is going to be our guess so far. And, the game is over if you either run out of letters or the guess equals the answer as strings. I guess they should be able to. And so I know we need to initialize the guess with underscores, one per letter. And I guess maybe I was thinking, or we were thinking, an array, the answer in array form would be handy. So I think, like, when we look for a letter, yeah, we need to check if a letter is part of a word. There's not really a good mechanism to do it in our string structures the way they are now. So converting to an answer, I mean, we talked about, well, maybe we should have at plus dollar or something, and something to get at a character in a string. And it probably would be good. But I'm kind of trying to do with what we have to see if we really have a minimal set, I guess. It makes things different. Like what's expedient for now, what's expedient in the longer run. It would be nice to have the length as a string. I mean, the length of a string, the character to position, and so on. And if we had that, I'd be much less tempted to do this array mess. Okay, and so I guess initialize was probably doing that, and we said, oh, wait a minute, that's really its own abstraction, and let's go do that instead. So I think that was the intent. And so S2A index, I don't know, that's probably something I expected to use in here. All right. And I don't know if this is of any, I guess it sort of gets us somewhere. Okay, so if let's assign. Well, the goal of this is we get a string and we get an array pointer, and we're going to write the string to the array. So let's figure out. Let's set the index first. S2A index 0 add equals. Okay, so we have this pointer that can walk through this string or know what array index to write to, I guess, is really the deal. All right, and then we're going to get the string Well, I think what we want to do is head dollar. Is that what we did here? Yeah. Okay. So let's take that. Oh, I should run these tests just to make it clear. All right. So let's run that. They should both fail. Okay. And then another thing I did a little of in my tests, I was printing out a dot for each one, but I think it'll be more useful for us if we put the string name of this. Now, if this were some sort of macro facility, we would have this built in, but we don't. Okay, so we'll print the name of the test, and then I don't know. Is there a new line at the end, maybe? Yeah, let's do that. Just as a normal part of a test. Okay, so it's bookended by the name of the test and a new line at the end. Okay, so test fails clearly. We got the head. Now we have. We're gonna have to do something like this. Whether it's not this, because we know that doesn't work. All right, but we have a character at the top, and if that character is 0, if it's not 0, we want to do some stuff. If it's 0, we want to exit. All right, and the thing we should do, because you might reuse this array, we want to make sure that 0 byte gets written out because nothing has been written. Okay, so I'm trying to make this first test pass. String array should be equal to empty string at the end after string to array. And I don't know if a range act setup kind of thing, is that too, I don't know, visually. That's kind of the deal. Okay. 1 0 assert equal. Okay, I think that was detecting that thing didn't work. Okay. Right. So at the end, and I'm just going to comment these because we don't want to handle that for anything for a non-empty string, but I want to do a write to well, what do I have on the stack at this point? I would have consumed that character, so I have C string prime and array. Well, the array is going to be built already, and we're going to assume it knows the size it wants to do. Mostly, I'm going to not worry about it. We don't have a mechanism to actually get the string length, which would be probably helpful. But I'll hold off, I guess. Okay, so C string prime array. Okay, so either way, we have C string prime array. So I think we know this. We know the character is 0 and the string is empty, so we can do a pop of those two, and then well, actually, we would really like to get, I mean, we got C, we want C on the top, a 0 on the top. Okay, so let's do A, C, B. So that says move the third element to the second. Okay, and so we have C string prime array. Sorry, C array. Oh, cannot type. String. Okay, and if we do a store, now we need to get that's progress, but we need the address in there too. S2A index at, that gives us index C array string prime, and we want to do a swap because we want the character index an array, and then at plus equals stores that, and we're left with string prime, and we pop. Okay, so swap these, get the index, which will be 0. Swap so the index is underneath, store, and pop. Okay, I believe that. And this was test string for empty. And this should pass. Okay. Good. All right. And now this test, we're going to take the array S to A. Okay, so we want to put cat in the string array. And we're going to test that string array at 0. Well, I don't want dot NL. I guess that's me printing to see what we have. Okay, so this, we shouldn't need that. 67 is a C, so that should be the first character, and then we'll just assert that the whole array is equal to cat. Okay, so, well, let's just rewrite this one. And it should fail. He's failing in an unusual way. Oh, infinite loop. Okay, because I don't do anything in here. All right. Well, let's get that then. So, we have the array on the bottom, the character, and then the string prime. So I definitely want to do ACB. Well, I kind of want to do this thing, right? Swap at equal. Yeah, we can't forget to increment the index. Okay, so this gives us C array string prime. S to A index gives us the index. Swap gives us C index array string prime. At plus equals stores that at the index. And then, did we have an increment? Well, we need to increment it. Whoops. S to A index. I don't know what we would call it. At plus plus. I think that was it. Yeah. At plus plus. Okay. So this plus 1, increment that index. Always critical for a loop. Okay. And then I guess we need to do a head dollar again, right? So then we got the string. We gotta get the loop through too. Oh, now I got array. We need C string array coming in. I lost the array. How do we get that guy in there? This is one of those things where that may be just easier to do a variable and call it a day, because trying to get down to the fourth thing in the stack is just really obnoxious. Okay. I guess I can. This is... Okay, I got C index array. I can do CAB. Gives me array C index. And then, oh no, I was going to say dupe. Maybe I got to do this differently. Too much stack manipulation is not a good sign. Okay, so I got C array string or C string array. Those are both not conducive to what we want. Okay, because I get here and I've got the array handy. Yeah. Well, even here, right? If I have three things, can I duplicate the array? I mean, maybe we need a four item manipulator, but right? Because if I bring it to the front and duplicate it, yeah, I got two arrays in the top three, and I can't get to the fourth slot. And I think this is why we introduced another variable in one of our other loops like this, because it just gets hard. But it's not test array. Let's do var s2a array. Let's store that. String array pointer. Let's do a swap. Oh no, let's do a BAB. Copy the second one up. Okay, so that's now array string array. And then s2a array at equals. Okay, so now we just have string array. Okay, and then I think we can proceed, and where we pull array out, well, we don't even need array anymore, do we? Okay, let me rethink this. Let's make this a swap. Array string array, and then store the array, and we just have string left. Okay. And now we have C string. We need to do S2A array and swap. So that introduces the array and puts it beneath the character. Okay. And then we want S2A index C array. Okay. C index array swapped. Yes. Cab. That's what I started throwing in. All right. I think we're getting there. This is kind of obnoxious. Okay. So we put the array up and then make it second. So now we have C then array, index C array, C index array, swapped, and stored. Okay. Ace to A index plus plus, and head dollar should go to C string prime. Okay. Well, I guess the thing to do is check it. And this is test S to A test. Should run them both. Oh, boom. Okay. Oh, do. All right. So segmentation fault. So it means I've screwed up something in here. Boy, this stuff with strings is really annoying. All right. Okay, so S2 array. Oh, I didn't initialize it. Darn. Oh, I did. Okay. Okay, so the array stores there. Head dog at C string. Dupe 0 not equals means we run it in here with either C string. Oh, this is different now. Okay, so ACB. Yeah, we don't want to do this. We got C. No, at the end we have C and string prime, and we want to get the array in. S2A array. Okay, and then S2A index. So now we have array C string prime. And here we have index array C string prime. Okay, and the order is just totally wrong. The C should be on the front, and then the index and the array. So CAB will do that. C index array string prime. Oops. Don't think I need that. Okay, sorry. We got the string. We load the array. We load the index. We really want the C on front, so we do CAB. Add plus equals stores that character there. And then we pop the string and we're done. Okay, I think that's a little better. Oh. All right, it's this. Okay, well. Okay, I guess it's better than a crash. That is a pointer, not a string. And the array is messed up. Okay, but this one's messed up first, so this is more of a problem. All right. Let's take this path of 0. Okay, so we save the array, save the index, split off the string, do the stuff to get through the loop, And down here, we come out with C string, which is 0 null string. We load the array. We load the index. And then we pull the C index array. Gosh, that seems okay to me. Well, let's go look at plus equals. I had it up. Here it is. Okay. At plus equals mem sub C indexed by B equals A. Okay, so C indexed by B equals A. All right, that seems okay. What is the deal? Even this is wrong. A equals... All right, let's make another assertion. Let's do test S2 array at 0 at plus should equal 0. Okay, so the first character of the array should be 0. Oh, he had a segmentation fault too. Well, I guess if 0's wrong, there's no chance. Make REPL. Okay. Okay. Let's start here. I didn't change any code, so something should... sorry, line 238 should add the 0 to the end of the array. Yes. So the first one, 0, should be the index because we didn't execute this line of code. So index array C, swap them around, C index array, and at plus equal should store the 0 into that slot. B is all over the place, so I haven't done something right on my assertion. Testers to a array. Oh, wait a minute. Oh, A is 0. B is something crazy. S2 array. And for the record, I like this better like this. I think it's doing a coherent thing, passing arguments to a function. Okay, but test array S2 array 0 at plus should give us the array in item at that value. And assert equal. This, I don't know. That's B is the address. Well, let's print this. We should get something in the middle. 43614. Golly. That's... I mean, we do at plus. Yeah, it's an address now. Well, I think its question mark is probably the last two bytes or the first two bytes. Well, we don't know what it is in hex. I don't know if I have the calculator up still. No. Okay. Well, it certainly looks like we have something that's a character. Something that's supposed to be a character is a pointer, so something's off here. All right, we don't do anything in the loop effectively. I mean, we have a character and a string. Is that right? S2 array at equals. Puts the array in front. Oh, wait. I think we trashed that here. I think this has to be a swap at equals. Okay, so we have the array on top and then S2 array. We want to store into S2 array, so the value has to be on top of the stack. So we have to swap there. Ugh. Okay, that's better. All right. And then I did not comment that stuff out. Okay, so let's see if this one's still good. Actually, not still good if that fixed this one. All right, this, because he had a segmentation fault before. A is cat, B is nothing. Okay. Well, that's kind of progress. A is expected, actual is 0, so we didn't copy anything. We just apparently immediately exited. Okay, so head dollar. I'm gonna print that. Maybe I'll print before. And I'll outdone it to make it stick out as being awkward. Okay, and so whatever that character is should be the front. Oh, well, what do we have here? We have the string. Okay, so the character should be the first character, the number of it. Duplicate it, not equal to 0, then we want to go through the loop. Okay, and yet somehow we seem to have exited the loop. Okay, so let's look in the loop again. All right, so we have the character and the string. We put up the array and do a swap. So we have the array address. Do I have to de-index that? Yeah. I need to get the actual array address. We have the address of the array, pointer to the array, but we need the array itself. So I think that's where that's off. At index. Then swap those. Okay. Let's take this. Interesting. I don't know what that means. That's not us. I don't think, because we don't write anything in hexadecimal. And certainly not as nice as this. It's dumping something. All right, let's do a make REPL. Sometimes just trying to overdo these creates its own problems. Okay, so now, well, this one should be good. 4, 0, good. Okay, and then this one is questionable. 499. Oh, 99 is a lowercase c. Okay, well that's okay, but that doesn't explain the rest of it. 96 is 32 plus 64, but we want 65 is a plus 32 is 97, so 97, 98, 99. Okay. All right. Boom, segmentation fault. So I pasted something that caused a segmentation fault. I don't know what. Whoops. Okay. And then we want to run this one. Oh, no error. Okay. Good. Okay, so where's that before? Get that out of there. Okay, so I think we've implemented string to array. Let's do it once clean and make sure. And it was test S2A. Okay, good. All right. Okay, I think that's actually a good thing. Awkward as it is. Okay, now let's pull this tests out. Okay, that's the real thing. I'm going to pull them into the test file, trying to get things a little more separated from the testing point of view. Okay, so let's take these. I'm gonna make REPL. Okay. And then these. Test all. Okay. Good, good, good. All right, so move test to separate file. Okay. Now, well, let's get that here. Our ideas are getting bigger and bigger. Get a clue. So we're getting to there. All right, so string to array. All right, then I just noticed this one. We have dupe 2 up at the top. Okay, so this took the first 2 items and duplicated them, A, B, A, B, C. And we have something that does that, but I think it's actually simpler. We really just need to do BAB, BAB. Okay, and this stuff goes away. So let's this is ABC goes to, sorry, ABC comes in, then we have BABC, And then we duplicate the second thing down again. We got A, B, A, B, C. Okay, which is what we want. Okay. And I guess if I do this, and tests. Okay. Okay. Oh, I see. Yeah. It is a little. I mean, we could have defined it to be like array name size or something, but then it would have been more. The array would have had to work harder to pull forward 2 times, But all right. Now let's go back to initialize. Oh, maybe it was something around this. So we have title. We actually overrode it here, I think. Title init. Let's make that one. Make sure that one is good. I guess we run title init. I don't think we need this line anymore. So let's do that. And then Hangman should just draw the scaffold with the title. The thing we were doing was I can't remember if we did this together last week or not, but we talked about it, turning it into an array of strings just like scaffold is. And let's make sure our routine actually does it that way. Yeah. Okay. So it's working the same. Excuse me. Okay, so next, well, are we here now? Right, so, well, let's take this. And I think I'm doing myself a favor doing that, and we'll always put NL at the end. And I think this can be a one-liner. Okay, so if we initialize the game with an empty string, then the game should be over. It's kind of trivial case, but I think accurate enough. Oh, okay, so this should already, this test is in here already. Test empty answer. I didn't change the print format, so it's just the dot. All right. That's true. Now this one, is that true? Yeah, if you initialize it to high, game over should be false. Okay, so test string answer. Boom. Okay, so yeah, that's where it's messed up. Some kind of. Yeah, it definitely makes sense to use draw at consistently throughout. Yeah, it was cleaning things up kind of revealed how bad that looked. All right, now I think initialize, right, it's kind of the half implementation of array to whatever, string to array that we wrote, this thing. Okay, and also I'm going to move this up. To me, it comes under the category of things that could be in the language already and aren't. Okay, so let's put it up here with all these. There's some string functions. Yeah. Did it do it? Yeah, okay. All right, so string to array. A couple blank lines, good. All right. We just have to watch that there's no definitions messed up. Okay, now here's stuff for our game. I think this should really be game init. Let's do that. Okay. But the implementation, answer index, I don't know. I don't think we need that. Answer string. Well, do we need the answer as a string? It's not clear to me that we do. Okay, we need the guess and the answer for sure. Is this guess? Maybe clue is the right word. I think maybe clue is the word I want to use, because guess is going to be the letter you're guessing, or maybe I think that's what that'll be. All right, so this is clue. Well, no, it is a guess by now, isn't it? Okay. Okay. So we want to, given a string, we want to do string to array. Now, string to array, already I can't remember what it took. Array pointer and string. Okay, so with the array pointer, we want to write answer and swap. So we have the string on top, and then array to string. Okay, so that splits, well, it does array to string. I think that's kind of okay. It doesn't really affect, that consumes the stack. So let's do a dupe. String, and then this leaves string. Okay, answer index. I think that was there because of all this stuff we were trying to do, the copy thing. All right, answer make $. Well, I don't think we need that. Okay, so this is getting much nicer. But I'll try and make this together so it's reasonable. Okay, so duplicate string, answer swap, array to string. So write the string into the answer. That seems good. Okay. Guess is already zeros. Okay. So that's well, okay. So I think that is good as far as it goes. Let's say it that way. Okay, so test empty answer and test string answer. This should work now. Okay. Hi, game init, game over, assert equal. Why are we not over? We expected 0, we got 1. Game over. Guess. Well, it's a 0 array, so its string is empty. We turn it into a string. It should be an empty string. Answer should, oh, yeah, answer make $. That should be our string. Well, let's say guess make $, empty string, assert equals string, and answer make $, hi, assert equals string. I'm going to put this one first because it's less likely to fail. Okay, this is kind of debugging stuff for me, so I'll just take this and replace it over here. A is high, B is not. Ooh, that's bad. Okay. So, answer array to string. Oh, we didn't pop that extra string because I know I want to do stuff with it. Okay, didn't matter. Hate that. Find one problem. Okay, so the first one succeeded. No, wait. Dot. Oh. Okay. High game init. Answer make $high assert. Why is there only two? A, string values different. B, passed. And C, values differ. Well, clearly test string answer, two string array is not working. Is that the problem? Let's see. So if I do 10 array A, and then I do, let's be fair to the other pets, dog, no, a dog, no, the array first, then the string, to string array. Well, I thought we were doing what needed to be done. What's the name of this thing? Array to string. Wait a minute. String to array. Oh, well. Okay. Oh, this is a flaw. Okay. The deal is, I didn't notice this. Okay, so our syntax errors in the middle of a big load can be very easily blurred in. So this string to array. Okay, yay. All right. See, this is where if we had implemented the import, I would think import would silently not print all these greater than 10s, it would just read the file, do the stuff, and any syntax errors that came out would be right there highlighted and called attention to. That happened once before, and it just kind of, I guess I noticed it and didn't really take the lesson that you have to do that. Okay, so all right, let's rerun from scratch. And I guess we can well, I think we're still going to be doing stuff with these, so I'm going to leave them here. So I guess what ran. All right, so test game init. Yeah, maybe we could do something. I mean, maybe the red compile mode is not ideal. Maybe red, maybe it should be like yellow, and then the red would pop out from that a little bit. Yeah. Maybe that would work. Let's go back up to it. Yeah, I think red really does kind of pop out. It's almost like it pops out too much because it's so buried. So let's make C10 be yellow, and then let's see where we go. So let's see, that's probably REPL, I would guess. Well, it's 10 greater. I guess it's input. All right, and then, well, 31 is red, 32 is green. Let's find a VT100 code chart. Four-bit colors. Yellow 33. Red text 31. Green 32, yellow 33. Well, I almost guessed that. Okay. Run prompt. Nope. Compile prompt. Okay. Let's do a make. Okay. Make REPL. Yeah, I can live with that. Okay. Now let's put something bad in here. Just some random kind of word. Take all these, do this. I did see red go by, but boy, there's a lot of stuff. Oh. Add plus plus. Well, seeing as I didn't notice this one before, I guess it's okay. But yeah, that's the style that it just writes the stuff. I guess it's filling up a buffer worth of text and then spitting it out, and then compiling and analyzing it, and then spitting out the next blob. Okay. Well, I think add plus plus is probably defined, but maybe it's out of order. I did move it. No, that seems okay. Well, it definitely could be up on the top section. And it uses nothing dangerous. But I don't know, something was funny there. Okay, so it uses dupe at 1 plus add equals. Those are all built-ins. Okay. And we gotta... This needs to come below this. Okay. Let's repeat that. Okay, that's the bad one. Okay, there's the new one. Okay, good. And that still works. Okay. Make C10 greater print in yellow so syntax errors are more visible. But I still need to be careful. Yeah, I don't know why it didn't have an error this time. Maybe Quadlibet made something else not compile that messed it up or something. Okay. Let's see. So we did this. All right. Given the word, create the initial guess. Okay, so, well, I don't know if that's exactly, it's not really string array. Yeah, except I think, when you're using it, if you typed it in wrong, you can just retype it. It's for that purpose, really. I want it interactive, and me trusting that I can do something without making a typing mistake and having to start all over every time would be really annoying. It might be better. It would certainly catch the syntax errors better. I mean, you could also imagine, well, you could also imagine turning on a mode that says, stop on error or something like that, and then a failed import like that would have been caught and stopped, and it wouldn't be any good, but it would be you would have that detection, and then you can go back to it in real REPL mode. You wouldn't have to have that, but I think once again I'm going to be a little bit messed up. I don't think we'll make that mistake a lot, but it could happen again. Okay. All right. So given the word, create the initial guess. Okay. Now this one, we don't have a length function at this level. We do have string length, and rather than writing another while loop like this, which wouldn't be terribly impossibly hard, maybe I should do that just for practice. That's a string function. Okay. So length $ is what I've used as a name before. That. Okay. And then test length of empty string. String dot dollar arrow, and then new line semicolon. Okay, so empty string length dollar zero assert equal. Maybe this might be better off like that. And yeah, let's do that. We don't need a lot of environment for this. Oh, okay. Guess we need more than I thought. Word not found assert equal. Yeah. Okay. One of our restrictions is you can't define words you don't have access to yet. All right, so let's do this again. Okay, and then this should fail. Okay, and certainly the easiest pass is to do this. Whoops. Notice I'm pulling this in again because I redefined this word. I gotta do this or I'll get the old definition. Okay. Good. Not surprising, but I'll take it. All right, and test length of non-empty string. Well, let's take another pet. Revit length dollar array bit 6 assert equal. Okay. All right, now this thing has to be a little more. Okay, so we got a string coming in. So string comes in, int goes out. The result so far is 0, and we'll take the head dollar, and that gives us character string 0. Okay, do no, while we don't need to keep the character around, so just not equal 0. Do if the character is 0, well, we consume the character, we have string index count. Okay, and then odd, and then we got to make sure count ends up on top. Okay, so I guess this is it 0 not equal? Oh yeah, thank you. Okay, so we have the character 0 not equal, that consumes that. Okay, so we want to increment the count. Swap 1 plus gives us count prime string. Yeah, exactly. All right, and swap again gives us string count prime. And then we're ready to and head dollar. Okay, this is keeping me honest, these comments. All right, so now it's C string prime count prime. Okay, so if the character is not 0, we'll do the loop. We'll bring the count to the front, add 1 to it, put it back second down. Do head again, so we consume another character and ready to go back through the loop again. At the end, we have string count. And so we'll pop the string, and the count will be the result. Okay. Oh no, test length of empty string failed. Okay, what's going on? Okay, length of 0, or count is 0. Oh, head dollar can't do that. Word not found assert equal. Okay. You can't really do this up here easily. Okay, so these two failed. Good. Good. Okay. And again, I'm going to pull these over. And I'll just do a fresh start here. And the tests. All right. Yeah, I don't know if that new line is good or not. I'm thinking it's kind of annoying, actually. All right, let's take these out. I think as long as I put a space here, then I won't overwrite things so totally terribly. Let's take them again. This part's kind of annoying. Good enough. All right. How are we doing? Good. Okay, so given the word create the initial guess. All right. Well, I guess what we did was implement length dollar. Because the guess needs that. Okay, so or init I think it's fair to assert empty answer. Yeah, game over. I want to make an assertion that the guess has those underscores in it. And game init should do that. And maybe it's more than that. So I think maybe it should check those field or those arrays that they have the right thing. This kind of did that. Guess should be that. I think that's actually wrong. Maybe that's the problem here. Yeah, so this should really be underscore underscore, right? Answer and guess. Okay, but game over should be 0. Okay, I think this line will fail, but the others will be okay. I don't know if I checked in. Yeah, we need an array of underscores. Okay, so test string answer. Yeah, okay, good. That's the line, or that's the code I wanted to trigger us to write. All right, so game init, it builds the answer. Okay, but I don't want to just pop that extra copy I made. Kind of looking ahead, I guess. I didn't have to duplicate it if I wasn't going to do something with it. All right, so now we've got a string. We want to get we got string. Well, I guess that's in the previous comment. We want length dollar. Okay, and that's just an int. And now the game well, I want to write game gets that many underscores. Okay. Now maybe that's well, let's write the loop and then we'll critique it. Okay. So we got the length. If it's not 0, 0 not equal, do odd. All right, so we want to say game. Well, I guess we want to duplicate it. Yeah, let's duplicate it here. Okay, so that gives us int, and that gives us just int. Okay, and now we have the value. Well, I want to say game. That's the array, right? Guess, sorry. Guess. Swap. Duplicate first. Yeah. Duplicate. Ugh. Okay, and now game swap. So I guess. How many times can I type it wrong? Yeah, guess swap, and then a string. And then at plus equal. And that should leave us with the int. Okay. And then we need to decrement it. Increment down. Right, we get out here, and here's array 0. If the length is 0, I don't know, maybe this is not the best way to do it. I keep saying that. We're writing, well, we really want to decrement it first. Yeah, I think if we, let's duplicate it, store a 0, guess 0, 0, at plus equals. Okay, so that leaves us no, it's guess swap 0 at plus equals. Okay, so that should leave an int on the stack, is that right? Take the length, duplicate it, guess dupe, or say guess swap will push guess on top of dupe of the int, and then we swap, we have int guess, and then we have 0 int guess at plus equals. So that writes the 0 at the last letter. And then I think we want to do it here. So what that int there is. We've got the int on the stack. We want to write it at 0. Yeah. So if we do 1 minus, we get int prime. Duplicate that, we get int 0 not equal. If it's 0, yeah, I don't know. Yeah, I removed. I got there. I think we're still not right here. Okay, because I got to make sure I'm working backwards, right? So it's kind of weird. So if I say 1 not equals 0, well, if I get to the 0, I have to write something. I want to write them in the loop. Well, yeah, so here I wrote the 0 at the last entry, because if it's a link 3, I should have A, B, C. Slot 0 is A, slot 1 is B, slot 2 is C, and then slot 3 should be the 0. So that's this. So I'm writing the rightmost character, and then I want to work my way backwards. I mean, it's like, I don't know if I want to count to -1. That seems really fraught. Maybe I should be keeping 2 things on the stack. It seems like I could keep track of that better. So length dollar and dupe, I'm going to have the index and the int. Yeah, I mean, we will. I would like to do a play again loop. So I think rather than trust the array got initialized to zeros, let's make sure it does the right thing. Okay, I think this is better. Now I have an index and an int. Okay, so I've got index. No, I don't want. Do I want this? 0. Okay, so if I have the index and the int, okay, if the count equals the length, let's do that. Let's do dupe 2, and then not equal, because we want count not equal to length. Sorry, yeah. While index is not equal to length, do stuff. Okay, so dupe 2 not equal. So this is index length. I think my comments more helpful. Twice. And then this goes back to index length. Okay, so while it's not equal, okay, if it is equal, then I want to put guess swap. No, let's do it when we get to the end. I want to say write 0 byte. Okay. All right, so now we got these things. We know we're not equal, index and length. Okay, and so I want to write something. I've got index on top. If I do guess swap, I'll have index guess length, and then I guess that's guess swap underscore. I'll have underscore. Okay, and I should be able to do at plus equal. Is that going to be right? So I have guess on the bottom, index and value. Okay, so I should be able to do that. Oh, but it's not this. It's it's an ASCII code. Ugh. underscore is high, like 126 or something. Is that it? No. Oh, he's down here. Okay, 95. All right. Saves answer string and creates initial guess. Note 95 equals underscore. Right, it was 95. Yep. Because it's just the character. Okay. Oh, you better guess than mine. All right, so we've written that character. We still have the length. Yeah, I gotta get that index before I. Okay, so coming in, we have index length. Right, let's duplicate that. Okay. Index length. Then guess swap with index 95. Let me put this in single quotes just to be. Okay, we stored that. All right, now we need to increment. So we have index length again, and then we can push 1 plus. We have index prime length. Oh. Oh yeah, that's 51, right? 3 times 16. Oh no, it's a little past those. Okay. All right. So is this as big a piece of code as I can write in one go, I think. Okay. We've got index length, We check them. If they're equal, we're done. Okay, then we have the index length again, so we duplicate the index. We swap around, so we have underscore index guess. We store it. We increment index. We have index length, and we increment the index. And then we come around again, and we're not doing anything with loop. Okay, we get to the end, and index is equal to length, so we can do 0 at, no, we need to guess swap 0 gives us, well, we had index, we added guess, so that should give us 0 index guess length. We'll do an at plus equal again, write that 0 byte, and now we have length and a pop. Okay. Yeah, just a simple while loop. Okay. Let's walk it from the top. So we have a string coming in. We duplicate that. We swap with answer. Oh, that stuff we already did. Okay, we have the string. We convert it to the length. We get the index counter as 0. We'll duplicate those two things and compare them. If they're not equal, that means 0 is less than length, really. We'll duplicate the index. Guess swap 95 gets that order. Add plus equal stores that in the guess array. Increment index. Come around the loop again with index length. Okay. Then we come out with index length. We push and swap again at plus equal, and pop the length. Okay. Let's take all this. Okay, I didn't see any red, but okay. And let's test this one. All right. Yeah, we'll extract that. So I think we're due for a break first. Let's take that break, and we'll come back and extract this. The other question in my mind is, this is sort of like a repeat. It's sort of saying store this value repeatedly in this thing for this many items. I don't know if it's worth abstracting that out as well, but we'll do that. All right, so 3 or 4 minutes, and we'll come back and clean that up and go from there. Welcome back. All right, we could extract string of routine instead or also. Yeah, I think let's do it also. Well, no, is it going to be so simple? So it would be, we want to say something like, guess the length and the character. Yeah, maybe we can extract that directly. Okay, so string of and it's going to take a, well, okay, so I think maybe repeat dollar. Okay, and then what's he get? Well, he's going to have the length. He's going to have an address, and he's going to have a character. We'll see what the order needs to be, but I think right now it's probably easily character, array, and a length. But we'll see what he needs. Okay, so let's take this. First starting point. Okay, so he needs index length. I don't know. This is it again. It's like 4 things. It's a habit. So character array length. When we get to this part, we have index length. I don't know. It's going to be 4 down. Well, let's see if this works first. We're just going to pass in length. Okay. So we got length, and then we're going to call repeat dollar. And then this stuff comes out. And I'm going to put it here just to not lose it. Okay, so repeat right now just takes the length. Okay. saw red. Guess. Yeah, I really want to get... I'll put it up here for now. See if this will work. Okay. And then we're going to run these tests. Well, test string answer is the real one that might fail. Okay, so that seems all right. Okay. Now to move that line back down, we're going to pass in the array. And then this is length, but he's also got to be guess. Repeat dollar. Okay. So if I've got the array on top, screwing things up, I know it's gonna get a little fraught. But really, you need to know where to put it, how many, and what character. Now, if I put in a variable, it just becomes trivially easy. So maybe that's the thing to do. Like I could pull guess into an array. Okay, let's do that. Well, no, how messy is it gonna be? Index length. I guess that moment is you've got index and you got to keep index and length around. No, I'm going to make the variable and make it easy on ourselves. Okay. This is repeat array. All right, and it's our temp. So let's store that array first. We want a repeat array swap at equals. Okay. This is store the array. After do, you only have two values on the stack before the dupe. Right, but if I had guess here, would that mess things up? I need to get guess duplicated, right? Well, maybe we can take a go. Before the index there, so I have, okay, so if I don't do this, okay, I have index array length. And then I have, yeah, I'm going to have, they're going to be in the wrong order for that. So let's do a swap first. Well, no, we don't need to do a swap. We can make them pass it the way we want. No, we can't. We can do the swap. Okay. Okay, so we have index array index length array. Okay. So this part should be the same. Those two get duplicated. You come back in here with index length array. Now we duplicate the index. Right. Now we get screwed up at this step, don't we? I need to get those three values on it. I need to have length and array, index and length. I need index, length, and array to do my loop, and so I can't duplicate all three of those. Okay, I'm gonna undo. Okay, I'm gonna do this with a variable and move the array before the dupe. Well, he would be at the end array. If I brought him up, then I've got four values in play, right? And I can't. I can bring him up. If I duplicate him, I can't get him all the way back. And I think I need him. It's a legit puzzle. I mean, I'm not saying I can't do it with what we have, but I don't know how. And I guess I want to pay the variable and just push on, but it would be good to have a pattern for that. If we could work out a pattern that gives us four things active, that would be kind of nice. But I think the most we can do is get, the third thing duplicated and put anywhere we want, but leaving the other two on top won't fly. Okay, so now we can't do guess. We got to do repeat array at gives us the address that is guess, swap 95, okay, and then this pattern again for guess, repeat array at swap 0. Okay, so let's index is on top, load the guess, swap, and then add the 95. Okay. I think we might be okay. I move guess down, and we're passing it first. Oh, okay. Repeat array at swap at equals stores that into repeat array. 0 index length. The length was on top of the stack, and length is now on top of the stack. Push the 0. Dupe to index length. Gosh, I don't know why that would. So I gotta make sure we have the ats in there. Where's the array length? It's popped at the end, but it's coming in, right? So the array and the length of the string. We don't have the character coming in yet. We'll get there. I don't know. Dupe 2 not equal. Okay, then dupe gives index index. Repeat at gives us repeat at index index. Swap gives us index repeat at index length. Array index length in that. At plus equals stores the array at the index. Repeat array. Okay, we come out. We've got index. Well, there's no guess here. Oh, after this. At the end, we got index and length regardless. Okay, and so we push the array, look it up. Now we have array index length. Swap it. Index array length and then the 0 index array at plus equals and pop the length. Now, I think I did a restart on the REPL there. I did swap things around a little, but I don't think I changed anything other than comments. Boom. Okay. Oh dear. Okay, var repeat array, and we store it. Okay, I'm going to print the length. And we'll print the value on top of the stack. So the link should come in. Okay, and then I'm going to print the dot 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 down here. After equals. Okay, so we should see the before and after. It's probably blowing up in the loop, but length is implausibly large. Okay. What are we doing? This should be this string, right? Okay. Right. equals high. Is length dollar not right? Why it should start breaking here seems a little implausible. Okay, so the string it prints is... Let's see what we got. Well, we don't know. Net is high. Make segmentation false 11. Okay, that string high is correct. Length dollar, and what did we blew up before we got here? Because we don't see length equals, right? Oh no, we do. Length equals something. We don't see after equals. But why is length so big? Oh, no. Okay, we're going to add some more here. Make sure I'm not seeing any funny business there. High, and it length equals 2. So I'm screwing it up somewhere before I get down there. Okay. This stuff looks okay. So guess swap means I'm passing in length on top, then guess into repeat dollar. He passes, well, that's backwards. Wait. I take the string length and then I push the swap. That seems wrong. Okay, so I have the length, and then I have the guess and the length, and now I have the length and the guess. And then when I come in here, repeat array swap, I'm storing the length instead of the guess. So it's really length array. But I took out a swap somewhere. I don't think I want this swap. Array then length is what I'm assuming here. So that blew up because I tried to store the string in the thing. So, all right. Okay. After equals, that's debugging code. All right. Oh. What did I just do? No, that should not have mattered. Let's do print and a print. Yeah, that should not matter. Why are you off? Well, what assertion is this? Test string answer. Why would answer be wrong? Repeat dollars should pop, yeah. And the other two are apparently right? Like, that's the piece I would expect to have stayed right. Okay. That should write the value into string to array. I mean, it seems like the second assert is okay. Answer. The answer equals, and then we should be able to say answer make dollar dot dollar pop. Answer make dollar gives a string and print the string and pop it. Saw something. String to array. I don't know if I've lost context. Wait a minute, that showed up there too. String to array. $287, $88. Okay. Yeah, I don't know if I can redo the whole package. Get this thing copied. answer equals high. And it works. So something is... Oh, I think I'll do a make REPL and it should be okay. Good. Okay. We're not calling this. Yeah, I don't know what broke. I mean, I think when I grab stuff and overwrite routines, I think that's mostly okay, but I think there may be a way you can screw up something. I'm not clear. Sometimes we have things that actually run at the top level, like these declarations, and then we have some inits that do. I think you can, undo an init or if you only replace part of it, you may miss an init or something that you needed, and I think that's what's the problem. Now, we still have one problem with this. I mean, repeat is great, but, we got this character too. Now, I don't know if we can get the character in there. Same thing. I'm just going to do the variable and be done with it. And I don't think... I don't think we can... Again, we would force too many things on the stack. I mean, the stack can accommodate quite a few, but too many that we need the top context of. All right, so repeat character. Let's pass that in. Underscore array length. Okay, and then down here, this 95. This was index array index length. Good. Okay. Okay. Now, this is generic, so let's move it up towards the top. Okay. I guess I'm going to just run that one more time because it seems like a simple refactoring, but it's not really. Okay. Good. Okay. Okay, good. Given the word, create the initial guess. I think we've done that. All right. Now, I'd like to just print it. And we have draw that works with strings, or draw at, rather. Let's see, there it is. Column, row, string. Okay, so I think this is kind of the I/O end of it. We'll let the hangman do it. We want to say guess make dollar. Let's do line 4. Draw at. Oh, we don't. We need to do an init. Do I need a column also? Yes. I thought I put it. Oh no. Okay. Maybe not the best visual, but on a bigger day, I'd like to put spaces between those, maybe. But maybe, I don't know. All right. But that's a good thing. Display the guess. All right. Given the word, draw the initial underscores. I guess this is just and draw it. Given the letter, determine if guess matches the answer. Whoops. I think we're doing it in the simple form, but determine if all guesses used is really the big thing. Okay. All right. So determine if guess matches answer. Well, we did that in the same test. Basically, our test was if the game matches the answer, if the guess matches the answer, the game was over. So we did check that already. Game loop, given a letter, update the guess. See, I don't want to do the loop until I've got the pieces. Okay, so we've got a short time. If you guess something, okay, this is a little tricky. Maybe we can get the test set up. Let's see. So this is test. What would we call this? It's while not game over, we're gonna read a character and maybe handle guess. Okay, and so the deal is we're gonna make a. Let's make a game. Cat. Game init. Okay, so we set that up, and now if we guess at, A was 97. 65 and 32. Yeah, 97. I don't know. I want to call that guess, but guess is already being used for something. Handle guess. Okay. And then was C is 99. Because 65 plus 32, so 97 should be A. I probably should do this all in uppercase too, just to be really old school about it. All right. And so what we expect at that point is that guess make dollar should be blank a blank. Or, yeah. All right. And then assert equal dollar. If you guess A, then the end game over should be false. That part's easy. Yeah, I was guessing A out of the middle. Sorry. All right. So we just checked. Okay, let's make REPL. Right. We don't have handle guess. Okay. Let's put it here for the moment. I guess greater is not a problem here. We'll consume that character. Okay. All right. So, well, I guess we have to loop through answer. So answer holds our array of individual letters. So we're going to loop through answer. If an index is equal to that character, then we want to update the guess in the same position. Okay, now we might be handling one too many things. Well, I'm going to assume handle guess is called with whatever the character from that key press. So the game loop, we might want to mock out the key press, although even there, I don't know. It's sort of the top level thing. If it really is like a few lines and one of them is do the read, I might be willing to just let that be its own thing. Or we can mock it. We'll see when we get there. That'll be maybe tomorrow if we're lucky. All right. Handle guess. Well, somehow we're going to have an index, right? So let's put the index on the stack. Now we have index character. Okay. And we, well, somehow, maybe I should take an easier case. Let's take an easier case. 99. Okay. So I'm going to say, if, I got to go answer swap. well, let's put answer first. Answer zero puts zero answer character. And then at plus gives me character answer and character. All right. And if characters equal, oh no, it's equals if v. Okay. Add some graphics. Yeah, we have to add graphics. Yeah. Right now we won't do the graphics, but handle guess we'll have to in the long run. So this is probably one piece. I gotta say update guess. All right, if the characters are equal, then I want to make guess zero dupe. Guess sub-zero equals character. Okay, so if character answer equals leaves just character on the stack. Guess zero, and then I want CAB at plus equal. Is that enough to pass? Yes. Okay. That's pretty primitive. But it gives us something. All right, I guess we're out of time anyway, but the next test is probably to do the test I started to do with A, and that forces this if to become a loop, and it forces us to keep character and index around. I'll call this index. So yeah, that'll be the challenge. So yeah, so I think future tests, maybe real quickly here, test for A in cat, test for A in dada, or maybe I can find a better word with two A's in it. Canal. Okay, so we want to make sure, yeah, multiple locations, and I think that's pretty good. You're right. We have to do the drawing and do drawing too, and maybe this update guess. Maybe you have to. Maybe the whole process is update the guess, update the hangman, or something like that. So. And again, that's a little tricky because, like, how many tries have you done and stuff like that. So we haven't dealt with that, but It's a start. All right. Well, we'll pick up there tomorrow, Tuesday. Yeah, drawing is for wrong guesses only. So, yeah, I guess that's the alternative, right? If the letter is legit, update it. Otherwise, update the body. All right. 2 to 4:30 tomorrow Eastern Time, or 6 to 8:30 p.m. UTC. Thanks for today, and catch you in the future. Take care. Bye-bye.